Welcome to Brain Vision.
So in this question, we are going to assume the energy produced per fission of the uranium is 200 MeV. And we're going to use that to solve what is the mass of uranium that was used. Now we're given that the energy that was released is 20 kilotons. Tons of TNT, and we want to convert that into joules, right? And eventually to MeV, right? So we can find how many fission has occurred, and from the number of fission reactions, we can infer the mass of our uranium. So to convert into joules, we use the hint that was given that 1 kiloton of TNT is 5 times 10 to the power 12 joules. So we take 20 times 5 times 10 to the power 12. This will be in terms of joules. To convert it into MeV, we divide by 1.6 times 10 to the power minus 13 joules per MeV. Right, and this would give us the amount of energy that was released in terms of MeV. Which is 6.25 times 10 to the power of 26 MeV. Next, we want to find the number of fission reactions that has actually occurred, and this will be equivalent to the number of uranium-235 that was used, right? Because each fission reaction actually uses up one uranium-235. So number of fission basically is energy released divided by energy per fission. Which we can get quite easily to be 3.125 times 10 to the power 24. So this is the number of uranium nuclides. To find the mass, we take the number of uranium nuclides multiplied by the mass of each individual nuclide. So that is around 235.04, but this is in terms of atomic mass units, so we're going to convert that into kg. Right, it's the conversion factor, right? 1.67 times 10 to the power minus 27 kilograms per atomic mass units. And we should get a value of about 1.23 kilograms, or approximately 1 kilogram. Right, so this is a rough estimate of the amount of uranium-235 that was fissioned during this process. Now, what was the actual mass that was converted to energy? We're going to use the equation E equals to mc squared. Since we already are given the energy is equals to the energy released, right? Previously we found over here 6.25 times 10 to the power 26. Sorry, that was in MeV, but we want it in terms of joules, SI units, right? That will be more easier to calculate, which is over here. I'm just going to use in terms of joules, so that's 20 times 5. (10 to the power 14 joules). we equate that to mc square, and to find the mass that was lost converted to energy, we just take 10 to the power 14 divided by c squared, which in this case is 3 times 10 to the power 8 square. And we should get a very small value, 0.0011 kilograms. So this was the actual mass that was transformed into energy.